Welcome to He Said, She Said, Poisoned RDP Offense and Defense by Dana Baril and Eyal Itkin in South Seas ABE. Before we begin, a few brief notes. Stop by the Business Hall, located in Mandalay Bay, Oceanside, and Shoreline Ballrooms on Level 2 during the day and for the welcome reception at 5:30 tonight. The Black Hat Arsenal is in the Business Hall on Level 2. Join us for the Pony Awards in Lagoon, JKL at 18:30. Thanks for putting your phones on vibrate. It makes it easier for the rest of us to ignore the ringing while you wait for your voicemail to pick it up. For the question and answer session afterwards, please remember to use the microphones available in the aisles. And with that, let us welcome our speakers.
Hi, thank you for joining our session about poisoned RDP offense and defense. Before we start, we would like to introduce ourselves. So my name is Dana Baril. I'm a security software engineer working for Microsoft Defender ATP. My job is to investigate new threats and develop new detections. Eyal.
Hi, thanks. Hi, I'm Eyal Itkin. I'm a vulnerability researcher at Checkpoint's research group. In this joint research, I was focusing on the offensive part. And now that we've finished with the introduction, let's begin. As you probably understood from the title of our talk, we're going to talk about Remote Desktop Protocol, or RDP, which raises the question about, okay, so are we going to talk about Bluekeep? No. Bluekeep is a different vulnerability in the Remote Desktop Protocol. It's an unauthenticated remote code execution vulnerability in Microsoft's RDP servers. This critical vulnerability was disclosed to Microsoft by UK's National CERT in May this year. It's gained a lot of media attention, and many security researchers fear that it might be used by threat actors to initiate a new wave of WannaCry like ransomware. However, in this talk we're going to present and focus on a different attack vector, which focuses on clients and not the server itself. Let's begin. The motivation for our research lies in what we define as lazy lateral movement. Usually, an attack on an organization starts in a way that the threat actor already has one computer that is already compromised via USB or phishing email or anything like it. And once he has a single compromised machine in the corporate network, it will use it to start the second phase of the attack, which is called lateral movement. In the lateral movement phase, the attacker will use initial foothold inside the organization and will try to exploit multiple vulnerabilities to spread throughout the network to compromise computers and servers alike in order to harvest as many credentials as it could, and essentially hoping to take over the entire organizational network. However, we were thinking about what if our threat actor doesn't have such a large variety of vulnerabilities. Therefore, we defined a new attack vector called lazy lateral movement, and this time our attacker will want strong users inside the network to somehow connect back to the already compromised single machine inside the network. If we could ambush privileged users and lure them to connect to our machine, maybe we could leverage this connection and exploit vulnerabilities over the connection to take over the connecting client. This could be applicable for IT staff. For example, we will want to harvest and collect strong credentials such as domain admin password inside the network. And for my day-to-day life, it could be applicable also for malware researchers. Malware researchers tend to execute malware samples on a daily basis in isolated virtual machines. And once in a while, the malware researcher will connect back to the machine and check upon the status of the malware. If the malware could leverage this connection and exploit a vulnerability in the software, it could escape the isolated virtual machine and infect the computer of the malware researcher. So essentially, our motivation is we want to lure people to specific machines and check if we could hijack the incoming connection. Once we defined this motivation, the goal and the subject for the research was quite clear. we chose to focus on RDP, on the remote desktop protocol. For those of you who are not familiar with RDP, RDP is used to connect to remote Windows machines. The basic terms of the protocol are that a client is going to connect into a remote Windows server. Although it's called server, it could be a remote corporate standard computer, it could be a physical server, and it could also be a local or remote virtual machine. You probably know RDP also as MSTSC, after Microsoft's built-in RDP client called MSTSC.EXE. And just as a side note, all of the attacks we are going to present in this talk don't require elevated privileges or admin privileges. Any user could perform the attack we are going to present. Now that we talked about RDP, what is poisoned RDP? In a poisoned RDP attack scenario, we already said that the threat actor has an initial foothold inside the corporate computer, and it wants to infect the IT staff. Instead of the malware staying stealth, as usually malware do, we'll try to do exactly the opposite. We will pop up random error messages, slow down the computer, and essentially do the maximum we can to make the life of the corporate user as miserable as possible. This is so that the corporate user will open up a ticket to the help desk saying, please help me, something is wrong with my computer. Hopefully after a week or two, someone from help desk will actually handle the ticket and connect back to our machine via RDP. This is where the attack starts. We will hope to find vulnerabilities in the protocol itself or in the RDP client, exploit these vulnerabilities, and take over the computer of the connecting IT staff. We could try to collect strong credentials from the victim, but our main goal will be to attack and take over the computer of the IT staff because we want to laterally move inside the network. Now that we defined what is poison RDP, it's quite clear that we're going to focus on RDP clients for this research. Okay, so we have several RDP clients. First of all, we have open source clients. The first client is our desktop. It's a quite basic RDP client. It doesn't support a lot of features, but it's the built-in RDP client in Kali Linux, for example. After that, we have FreeRDP. FreeRDP is way more mature. It supports many more features, and it's way more popular in GitHub, as you can see over there. And last but not least, we have a Microsoft's built-in RDP client called MSTSC.EXE, which is by far the most widely used RDP client out there. Having 3 clients, we had to decide, okay, where should we start? And we decided to focus on the easiest target to begin with. And this is our desktop. Our desktop is open source. It supports the least amount of features, and it has least amount of code lines when we checked it out. So our desktop was a clear choice to begin with when we want to start with the easiest target. Being open source, we could audit the code and actually learn how RDP works, because up until now, no one described to me how the protocol actually works. And from my personal experience, auditing the code and learning from the code about the protocol is much more useful than reading the standards, because you can only see features that someone actually implemented, and you hope that people actually use these features. But if you read the standard, you can find a future annex or an appendix that no one actually implemented by the industry. So auditing the code is my preferred weapon of choice. And so we started auditing the code and learning how RDP works. The goal was to focus on potentially vulnerable features and modules. So hopefully we'll have a specific feature that is prone to errors or vulnerabilities, and maybe it will include vulnerabilities in multiple RDP clients and not only in our desktop. Gradually, when we audit the code, we gain confidence, and once we think we finished covering all of this specific client, we'll move on to the next client and continue on with our research. Auditing the code, we learned a few things about RDP, and this is, the protocol consists of logical channels. This is a modular design. That means you have a channel for audio, a channel for video, and a channel even for clipboard. So you have a channel for everything, and in the code audit, you just need to know that you covered each of the channels. Just as a side note, Bluekeep will exploit vulnerabilities in the internal MST120 channel, which was supposed to be private but was public and accessible to clients as well. In addition, RDP have support for multiple authentication methods. It's not really interesting from our side because in our case, the server will exploit vulnerabilities in the client, and the client is supposed to authenticate itself against the server. So the server could essentially say, yeah, you're okay, please connect, and then exploit the client. In addition, we have screen updates. When you see a screen, you get several updates, and each update is represented as a bitmap. Not a PNG file, not a JPEG image, plain old bitmaps, and that's it. And as I mentioned earlier, we also have basic clipboard types that are shared between the client and the server computer. Now that we learned about the RDP protocol, we audited the code of our desktop, and we actually found out that our desktop uses really naive C code with less than minimal checks most of the times. Most of the times there are even no checks that minimal input was received before someone actually parses a packet, which is quite a common mistake in implementations of network protocols. And we find a few interesting vulnerabilities according to this specific bug. Overall, we found 11 critical vulnerabilities in this specific client and 19 vulnerabilities overall, which was quite high. Here you can see the list of the CVADs. And if you'll do the math fast enough, you can see we have only 10 CVADs in this list. And that's mainly because we weren't planning on finding so many vulnerabilities in our desktops, so we ran out of CVADs. We had to ask MITRE for additional CVADs for this research. We got an additional bulk of CVADs, and here are the full list of vulnerabilities for this specific client. We found much more vulnerabilities than we hoped for, and we hope this is a good start for the next clients as well. In addition, we also found a complicated feature, and it turns out that parsing bitmaps is actually complex. When you send a bitmap update, it has its own width, height, and amount of bits per pixel. The attacker can control each of these fields, which are 16 bits in length. Afterwards, all of these fields will be multiplied to allocate a heap buffer that will contain the decompressed bitmap that was sent over the channel. However, since we as an attackers control each of these fields, if you position these specific values in each of the fields, upon multiply, it will overflow the 32 bits of the variables and will get truncated down to the value we can see over here. And this means that the logical size of the allocated buffer will be smaller than the actual size, sorry, of the allocated buffer will be smaller than the logical size that the decompression will try to use. So we actually are going to write more bytes over the heap buffer, essentially giving us a heap-based buffer overflow when decompressing the bitmap. So we mark this thing up as a complicated feature and hoping we'll find it again in several RDP clients afterwards. Okay, we finished with our desktop. It went quite good. Time to check if we have more luck with FreeRDP as well. And FreeRDP was a tough target. The C code looks better. It still has a few cracks when you look deep enough, but it has more checks, it's more documented, it supports more features, it has better code quality. However, it's still vulnerable to the exact same bitmap parsing we've just seen, so we had a good start. We found 5 critical vulnerabilities in this client and 6 vulnerabilities overall, and here are the CVADs for FreeRDP. So we found vulnerabilities in our desktop, we found vulnerabilities in FreeRDP. Time to check if you have more luck with Microsoft's client, MSTSC.EXE. Thanks. And in short, we had less luck with MSTSC.EXE. We tried all of the POCs from the previous vulnerabilities, simply executing the script and checking if they work. And RDP client simply closed itself with no crash, no warning, nothing. So all of the previous vulnerabilities don't work. So I started reverse engineering MSTSC.EXE. And we can even see that the code is more robust. They actually use smart buffers to check for parsing errors, which is quite a good protection against most parsing vulnerabilities. And you can actually see when you audit the code that MSTSC.EXE includes many more features. It's way more complex, and it's in several orders of magnitude better than the open source clients we previously audited. It's going to be a tough target. And at this point, we're kind of stuck because all previous leads fail us. So essentially, it's back to the drawing board. And at this point, it was actually back to the clipboard, because up until now, the clipboard shared basic text types. We had CF text for ASCII and CF Unicode text for, well, for Unicode. Because Linux machines had to specifically support each format when connecting to the remote Windows server. But when you have a Windows machine connecting to a Windows machine, you can essentially synchronize the same clipboard on both machines. So Microsoft supports many more formats now, and we have a much broader attack vector in the clipboard itself. So let's dig in on how the clipboard actually works. You'll probably be familiar with the clipboard. You use it on a daily basis. It's a kernel data structure that stores, well, data. You have one clipboard per session. From our perspective, it's in one clipboard per RDP connection. And it's shared between processes, because usually you copy your password from notepad.txt to Chrome. So it's shared between the processes. The data itself is stored by ID or by name. You have a format ID or a format name for each format. And you should really be cautious when using the clipboard. Clipboard data should not be trusted. You should really parse the data carefully before you use it in your own application. And if you think it's only me saying that, that's actually a quote from MSDN. Immediately when we saw this quote, we knew we were going to find vulnerabilities, because that's a good quote to, okay, no one will check the data, we're going to be fine. But we are interested in the clipboard over the RDP protocol. And everything in the clipboard is going to be synchronized automatically. And the clipboard is defined as a shared resource, and it's shared by default. And this means Microsoft only uses blacklists to filter out specific formats, but they're using blacklists instead of whitelists. So it's not a good security perspective, but from an attacker's perspective, that's good news. We're probably going to handle these blacklists. So you have a blacklist for formats that are going to be discarded by their ID, and a blacklist for formats that will be discarded by their name. And one final note, on RDP, you have something called delayed rendering. This means that when you copy something, you only get the list of available formats, but not their content, because it could be heavy to copy all of the data if you're not going to paste anything. This means that if you copy a password and close the RDP connection, you won't be able to paste the password. You only know there's something of text, but you don't know what's the text because no one sent it to you. And here where it becomes really interesting, because essentially you have also drag and drop. Drag and drop is the internal name Microsoft uses to copy files. And file copy operation uses multiple clipboard formats. You have one format called CFH drop, which lists the file names, an additional format called file group descriptor with all of the full metadata of all of the copied files, and you have additional many more formats for file copy operations. Let us now see how it actually works in practice. We have a user on the right going to copy a file from the RDP server on the left. When our user is going to initiate the copy operation, it will populate the clipboard on the server with all of the formats necessary to copy files. The server will then want to notify the client about each of the available formats. So the first format is CFH drop, but it's going to be filtered out by the blacklist. And we have also shell ID. And essentially, only file group descriptor will pass the blacklist, and that's it. Only this specific format. And since we have delayed rendering, the client only knows there's an available file group descriptor, but not its content. Once the client will start to paste, it will request the file group descriptor from the server. The server, for some unknown reason, will intercept this request and exchange it with a request for CFH drop, and request a CFH drop format from its own clipboard. Once it gets the data, it will manually convert it back to file group descriptor that the client initially asked for, and will send the data itself to the client. Now the client knows which files were actually being copied on the server itself, so we could query for the file content of each file and get the copied file back to his computer. And that's essentially how you copy files over RDP. The main structure inside this process is file group descriptor. File group descriptor is a proprietary blob structure. It contains a list of file records, and in each record we can see we have a metadata, for example timestamps, and the file's path. And in our examples, it should always be the file name of the copied file. The client will get the data from the server and happily pass it on to the clipboard. At this point of the research, one of my team members, Omer, told me to try to find out where they sanitized the received path. So I tried. I really tried. But I couldn't find anywhere where they sanitize the path. So I told the server to send a file name of /filename.txt. And the client happily received this file, stored it in the clipboard, and even Explorer.exe happily notifies us that he is now going to copy a file name called /filename.txt. And this essentially means we found a path traversal over the RDP protocol. We notified Microsoft, we received an official CVE for this vulnerability, as you can see. And to break this down, when using copy and paste over RDP, a malicious server can drop arbitrary files to arbitrary file locations on the client's file system. You can simply drop your malware into the starter folder of the client, and that's it. Upon reboot, you have code execution on the client. But we wanted more. If you take it one step further, the clipboards are fully synchronized. This means that when you copy, you update the clipboard. This sends a clipboard DR format list message to the other side, and the other side will update its clipboard accordingly. But what does it mean? The first scenario is eavesdropping. If you copy a password, I get it too. And that's not a bug. That's an actual feature because the clipboards are fully synchronized. But it also means that if the client is copying a file, I know about it too. So this leads us to the second scenario, being paste-only attacks. In a paste-only attack, we once again ambush the client. When the client is going to copy a file, we will start our own attack. We will send an update message and tell the client that we also copied something and send him our malicious file group descriptor with the path traversal. When the client will unknowingly paste the data, it will trigger the path traversal we initially prepared. Did we break them all? We find vulnerabilities in the 3 most popular RDP clients, so it's probably yes, but no, we didn't break them all yet. Time to move on to HyperV. I never used HyperV till now, but Microsoft allows you to use virtual machines on your Windows operating systems using HyperV technology. This means I installed a HyperV on my Windows machine, started a Windows virtualized machine, tried to connect to it using the HyperV GUI manager, and I saw this suspiciously looking dialog box. This is the exact same dialog box from RDP, but I used HyperV manager, not RDP client. And you can even see that the clipboard is shared. Behind the scenes, Microsoft uses RDP for accessing the virtualized machines even when you use Hyper-V on your machine. And that's mainly because Microsoft already implemented the code needed for seeing the screen, sending keystrokes, sharing the clipboard. So there's no real need to re-implement the wheel and implement again all of these features. Microsoft decided to simply use RDP for the GUI connection in your Hyper-V manager when you use Hyper-V VMs. So behind the scenes, we actually have RDP. Once I saw this dialog, I simply ran again the same POC I had earlier for RDP, and it worked on the first attempt. And actually, this means that the same path traversal over RDP is now a guest to host VM escape from a Hyper-V virtual machine. So let's see a video. This is a video over the Hyper-V test case. When we start, we can see that the client's startup folder is empty. Now we'll try to connect to the Hyper-V machine using a Hyper-V manager. Initiating the connection. Just a plain old VM, that's it. And as you can see, it's a plain old VM. It's a malicious VM, but the client doesn't know it yet. And now when the client is going to copy an innocent text file from his local computer, we'll hijack this operation, prepare a malicious file group descriptor, and when the client will paste the same file on his computer, our startup, the startup folder of the client will contain our malicious script inside it, because we hijack the copy operation with a paste-only attack, and that's it. After the reboot, the client will execute our malware from his startup. One last note, WDAG. WDAG stands for Windows Defender Application Guard. This essentially means you have a virtualized edge browser you could use to browse risky websites safely. You need to see your edge browser, so once again, use RDP to connect to the remote VM. This time we use HVSI RDP Client instead of MSTSC.EXE. This change means that Microsoft decided to once, in this case, use whitelists instead of blacklists. And the clipboard starts off by default. And when you use it, you can only use two format types, for text or for images, and that's it. And this whitelist blocks our attack and means that essentially it stops our vulnerability. You can't use it on WDAG. That's good news for Microsoft. And time to move on to the defense part by Dana.
So Eyal reported his finding to Microsoft through the bug bounty program. And then Microsoft started to analyze all his findings and started to work on a patch. And this is where I stepped in, because I was thinking to myself, you know this moment where a new patch is released and a new vulnerability is published and everyone are freaking out trying to install the patch as fast as they can in order to stay safe. I tried to find a solution for this scenario. And this is where I realized that a patch is not enough, because users remain vulnerable until they install the patch. So I was looking for a way to protect the users without any installation, without any need to install the patch. So what I tried to do is to develop a new detection based on existing telemetry that already exists in Windows 10 versions. So this way, customer can stay secure without updating to the new patch. So I have a few ground rules when I started to work on my detection logic. So my first rule was, yes, I should use only existing telemetry in Windows 10 that are already available to the users. My second ground rule was that I should be able to detect this breach from the victim side, from the victim machine. So as Eyal mentioned before, we have two machines here. One machine that is already compromised, which we mostly refer as the server machine, and one machine which is the client machine, and this is where the attack is moving forward to. So I tried to develop a detection from the client side and protect the client from this threat. My initial instinct was maybe to use an RDP anomaly detection, but unfortunately for this attack scenario, this detection won't work. The reason it won't work because we don't have any RDP unusual behavior in this scenario. The user is initiating the connection, and therefore we won't expect to see any abnormal behavior in this case. So I had to work harder. I decided to use existing telemetry from Windows 10, which called ETW. It stands for Event Tracing for Windows. And this is a built-in tool in Windows for all Windows 10 versions. This is basically a Windows API that allows Windows applications developer to trace their application. So this way, they can track the different flows, they can see which exceptions were thrown in this application, they can see the performance, so they can basically get information about the usage of their application. So as you can see, the ETW events are not originally created for security perspective. However, we can find them very useful for many scenarios. So for this attack scenario, I used two different ETW providers. The first provider is the RDP Connection Provider. The RDP Connection Provider includes multiple events. I decided to use two specific events. The first event is event 131, which is triggered when a new RDP connection is accepted. The second event is event 132, which is triggered which is basically a keep alive event. So it is triggered every once in a while, notifying that the connection is still alive. The second provider I used is the Clipboard Provider. This is a unique provider since this is a non-manifested provider. The meaning of non-manifested provider is that we don't have a manifest file that includes all the information and all the events that this provider provides. So in order to understand which events are included in this provider, we actually have to check the code. So the Clipboard Provider includes multiple events. I specifically used a specific event that includes the API name. So it basically triggered every time an API from the clipboard is called. It includes the API that is called, so it could be get data, set data, other clipboard APIs. It includes some information about the format that was copied and the medium that it was copied to. And it includes information about whether the API call was successful or not. As you can see, I was surprised as well. We don't have here the clipboard content information. So we don't know which file was copied, we don't know which text was copied, and initially I was surprised, but after I was thinking about it for a while, it actually makes sense. There are multiple reasons why we don't have the clipboard content in this event. One reason is focused more about the size. I mean, we don't know what's the size of the text or the file we're copying, and therefore we don't want to parse that. But I think the major reason we don't have the clipboard content in the clipboard events is because we want to make sure the user's data remain private. So if the user, for example, copies a password, we don't want this password to be available in clear text in the logs, right? So it actually makes sense, and I can understand this boundary, why we don't have the clipboard content in the clipboard event. So before we can talk about the detection logic I worked with, we should see a demo. So I basically ran the same scenario that Eyal showed before. The only difference is that we're going to have an additional window on the bottom, and this window is a tracer. So you can see all the different ETW events that are triggered during the attack scenarios from the victim side perspective. So we initiate the RDP connection, and then we can see that a new RDP event is triggered, and then I copy a file, and when I paste the file on the client machine, we can see that multiple clipboard events are triggered. The reason we have multiple events and not only one event is because multiple files were pasted behind the scene, as you could see before. So I took this telemetry and tried to work on a very basic detection logic using only those ETW events. So my initial detection logic was, okay, so I can recognize that I am using that the client machine is in RDP session. You can use event 131 or event 132 to recognize an RDP connection. And then we can see that if during RDP connections we are pasting multiple files to the victim machine in a short period of time, we should suspect this case. We should say, okay, so multiple files were pasted to the victim machine, so maybe we are vulnerable to this vulnerability. Maybe it was exploited on our machine, and we should basically define this machine as suspicious. The reason I define this machine as suspicious and not as already compromised is because I'm not sure if this is the attack scenario or not. I mean, maybe the user pasted multiple files. Maybe it's an actual user behavior. So my recommendation in this case will be we should maybe trigger a scan, should scan the machines, scan the different files, and see if we find anything suspicious. So as you can see, this detection logic is very basic, and I was looking for a way to improve it. So in order to improve it, I needed more data. So I decided to use a file creation event. File creation events are very popular. Almost every security vendors are using file creation events, and there are multiple ways to implement them. The basic idea here is that we trigger an event or any other indication every time a new file is created in the machine. In order to implement my improved detection, I decided to rely on two very basic data properties from the file creation events. And this is the file name, the file that was basically created, and the file creation time, when the file was created. So now I have more data, and I can create an improved detection logic. So my new detection logic starts right like the basic detection logic. So we recognize an RDP session, and we recognize that multiple files were copied. But now with the new data, I can correlate the file creation time with the pasting operation timestamps. So this way I can actually extract the file name, so I can recognize which files were pasted, and I can see the directories. And this way I can see if directories are different. So if basically multiple files were pasted to different directories, it means that we were breached using this vulnerability. So in this case, we would like to alert and react accordingly. So yes, I covered the scenario. I have a detection logic. We're safe now, right? So as an experienced defender, I knew at this point that this detection is not enough. This detection is custom made for the specific attack scenario that Eyal described. But there are many attack scenarios out there that are very similar, and I was worried that if the attacker will change just a minor step, I won't be able to detect it anymore. So the way we like to think about detection in those scenarios, we try to learn the different malicious behaviors that we can recognize in the attack scenario and cover them by detections that are covering the behaviors and not the specific steps of the attack scenarios. So I look back on Eyal's attack scenario. I tried to recognize behaviors. I recognized three malicious behaviors. The first behavior I recognized was the startup folder as a destination. So the idea in his attack was basically dropping file in the startup folder. That was the goal of the attack. So I tried to find an approach how to detect this malicious behavior. So there are multiple ways to do so. One way would be maybe an anomaly detection. We can basically trace new files that are created in the startup folders, recognize anomaly detections based on multiple features from the file creation events. And the other way is a more rule-based detection, which basically is scanning and analyzing each new file that is created under the startup folder. So this is the first behavior. I recognize another behavior, which is the clipboard as an attack scenario or as an attack vector. In this case, we can cover or detect this scenario using file pasting anomaly. We can use features like the number of files that are pasted or the directories of the files and recognize anomaly scenarios. The last behavior I recognize is the malicious file, basically just general malicious file dropping. So the goal was to drop malicious files to the victim machine, and the best way to detect this behavior, is basically by file creation anomaly. We can use features like the file name, the file path, the file creation time, and so on. And now when I feel that our customer, our users are safe and can actually keep working without any updates, we can talk about the updates. So Microsoft released an OS patch to Windows 10 in last July Tuesday patch, which includes this fix for this vulnerability that Eyal reported. And actually the fix was very simple. So basically a new method was called in the clipboard flow, and you can see here in the binaries that this new validate file path was called. And this new method basically verifies before every pasting operation by extracting the file, the canonical file, extracting all the file path, comparing it to the file name, and making sure that they are aligned. So basically, before every pasting operation, we verify that the file we are pasting is actually the one we meant to paste. So to summarize, I would like to share with you the lessons we have learned during this research. The first lesson is about connecting different modules. So as Eyal mentioned earlier today, the clipboards were designed initially to be used locally, and they were not designed to be trusted because multiple applications can access the data in the clipboard, but the user behaved and interacted with the clipboard as a safe clipboard, as a trusted clipboard. When Microsoft introduced a new feature for sharing multiple machines, it made sense to make the clipboard shared between those machines. It's a very basic user experience, and therefore it was natural to have this feature available for RDP connections. However, this exposed machine to a clipboard they can no longer trust. And this is how basically this vulnerability was introduced. The second lesson we have learned is about Windows telemetry. We realize that Windows telemetry is an important tool in the Defender steelbooks. It is very useful for defending scenarios, for defending models. But we actually see attackers using the Windows telemetry into considerations when they perform new attack techniques. So for example, we see many attackers clearing the Windows event logs before they after they finish their malicious activity in order to cover their traces. The last lesson we have learned is about how our industry can benefit from this cross-community collaboration. So thanks to the trust and the transparency between the security community, we could find new vulnerabilities, we could effectively protect users, and we can fix them and share it with everyone here. Before we move to the questions part, I just want to say that Eyal and I wrote a very detailed white paper that includes all the information about our research, and we would like to share it with everyone. Thank you. We have time for about 2 questions.
I think you have a mic on the right, on the left.
Please use the microphone.
Use the mic so people could hear the question.
Go ahead.
Since you fixed it in Windows 10, how does that relate to Windows Server editions or Windows 8 that's still supported?
The patch was released on July's Patch Tuesday, and it covers practically all of the OS versions for Windows because it was applicable for the RDP client in all versions. So the patch covers Windows 10, but it also covers Windows servers, Windows 7, and so on.
Also, you have a Mac client. Have you shared this with your Mac team to work with them at all? With your Apple team?
Can you get closer to the mic?
I'm sorry. You have an Apple RD client. Have you shared this with them so they can fix it on their end as well?
When I tested it, it seems that on Apple products, they tend to use a free RDP or a custom version of free RDP, and free RDP patched all of the vulnerabilities roughly at January this year, so they should be okay. Same thing for our desktop, which patched it on February this year. All of the vulnerabilities we've shown in the presentation were patched, and the patches were already released to clients.
Thank you.
Hi. In your detection scheme, you shown that pasting into the startup directory is a suspicious activity. But how about dropping files to other directories?
Yes. So as I said in the last malicious behavior that I recognized, basically file dropping to new machines. So we basically would like to detect different cases of file creation on the machine by anomaly detection. So this is how we cover this scenario.
Thank you.
Yeah, I have another question for you. In the Microsoft version of the MSTSC, there is a checkbox for enable remote level or network level authentication. Did you turn that on or use it, or did that change the outcome of what you've been doing?
Since the vulnerability is when you have a synced clipboard, and it uses the clipboard channel, and the clipboard channel is the most internal logical module inside the RDP connection. This means that it has nothing to do with the authentication or anything you use, encryption, compression, anything about the RDP protocol, which even makes it harder for network-based products to filter out this attack scenario and have an IPS detection, for example. The only thing you can do for your RDP client to be safe if you're not patched is you can simply disable the clipboard sharing synchronization. And this means you won't have your clipboard, but you won't be vulnerable too. Anything otherwise will stay the same. The vulnerability will stay. It will be exploited exactly the same. It won't change nothing in this scenario.
Thank you.
You mentioned there was a white paper. Where can we find that?
In Black Hat website. I'm not sure exactly when it's going to be released, but it will be there.
Great, thank you.
Hi, over here, other mic.
Yes.
Great presentation, by the way. I wanted to know, it was unclear to me how you performed the attack. How did you inject the column, slash or backslash, whatever Windows uses? So was it through OS DLL modification, like hard coding the things in there, or did you use some process and man in the middle, or did you use like clipboard, like something constantly changing the clipboard? How did you perform the attack?
Okay, it's a good question. We have all of the details in the white paper, but it's actually not plainly obvious. What happens is on the server you have a service for RDP, but I told you that the vulnerability could be exploited without elevated privileges, so without touching the service. And it seems that the service is using an additional process called RDP Clip, and RDP Clip is a broker for the clipboard. So I patched RDP Clip to load my own DLL, and when I see someone copies a file or pasting a file, it will redirect the logic to my DLL, and my DLL will replace the file's path with ... after RDP Clip was supposed to verify the path on its own. Actually, RDP Clips verifies the content of the clipboard, so if you manually change the clipboard and that's it, the attack won't work. You can think of it on a client-side verification on the server. So I patched RDP Clip. RDP Clip simply sends the file group descriptor to the service. It will later on be sent to the client, and that's it. So eventually we had a patched version that exploits the vulnerability when you copy files.
Excellent, thank you.
Hello. So you mentioned that this detection was based on the logs and the events which are being generated on the client side, and they were probably being sent to Microsoft, the mothership. So are these events sent to Microsoft even if the user has turned off the diagnostics or sending out the diagnostic events? My question is is this detection going to cover all the clients or only those clients which have enabled the diagnostic events to be sent to Microsoft?
So yeah, this is a very simple detection technique. By the way, I didn't mention, but 94% of the pasting operations includes only one item. So this actually detection is actually very useful. You can use it on your own machine without any security vendor installed on your machine. You can just basically implement it by yourself using the ETW event providers. I specifically work on Microsoft Defender ATP, so I implemented everything itself in our product.
Thank you.
It can be used by any security vendor since it is used, but we used only built-in telemetry.
Cool, thank you.
Cool, thanks for coming.